Who's ready to party? Jeff and Chad, are you ready to go?
I know I am. Can't wait to go have some fun, Lauren. How about you, Jeff?
I am so down, but remember, we can't drink because it's finals week. Gotta be prepared for the exams. Calculus is kicking my butt this year. I wonder how I can get a better understanding of derivatives before the exams.
Oh, don't worry. We will be totally fine. I'll quiz you guys along the way, and we can use the people at the party as examples of derivatives based on how drunk they are.
Oh yeah. Totes my goats, my dudes. Now let's go party.
Alright, let's go have some fun and be safe.
Alright, let's go.
Hey, Lauren and Jeff, I propose a little competition. Let's see who can find the most wasted person at the party. They either had to be completely plastered or try and do some crazy stunt.
Sounds like fun idea to me. It'll also help us understand our derivatives better at the party.
Sounds good to me. As long as nobody gets hurt, I think we should be fine. Now let's go get in the car or we'll be late. Hey guys, turn the music down or turn it off please.
Hey, what's up, Jeff? Something wrong?
A little bit. I just want to go over the derivatives again and how we can tell what they are.
Alright, we can start with the chem example from class. Can you explain it to me, Jeff?
A chemical reaction results in the formation of one or more substances called products from one or more starting materials called reactants. For instance, the equation 2H2 plus O2 means 2H2O, which indicates that 2 molecules of hydrogen and 1 molecule of oxygen form 2 molecules of water. Let's consider the reaction of A plus B equals C, where A and B are the reactants and C is the product. The concentration of a reactant A is the number of moles per liter and is denoted by A. The concentration varies during a reaction, so A, B, and C are all functions of time t. The average rate of reaction of the product C over time interval is T greater than T2, is delta C over delta T equals CT2 minus CT1 divided by T2 minus T1. But chemists are more interested in the instantaneous rate of reaction, which is obtained by taking the limit of the average rate of reaction as the time interval delta T approaches 0. Rate of reaction equals limit of delta T coming to 0 of delta C over delta T equals D of C over D of T. Since the concentration of the product increases as the reaction proceeds, the derivative D of C over D of T will be positive, and so the rate of reaction of C is positive. The concentrations of the reactants, however, decreases during the reaction. So, to make the rates of reaction of A and B positive numbers, we put minus signs in front of the derivatives, D of A divided by D of T, and D of B divided by D of T, since A and B each decrease at the same rate that C increases. We have rate of reaction equals D of C over D of T equals negative D of A over D of T equals negative D of B over D of T. More generally, it turns out that for a reaction of the form little a times big A plus little b times big B turns into little c times big C plus little d times big D. So we have negative over little a times D of A over D of T equals negative 1 of over little b times D of big B over D of T equals 1 over little c times D of big C over D of T, and so on. The rate of reaction can be determined from data and graphical methods. In some cases, there are explicit formulas for the concentrations as functions of time, which enable us to compute the rate of reaction.
So do you understand it more after going through the example, Jeff?
I understand the derivative a lot more and what it means, but I feel like there's so much more to it all.
Totally tubular, my dude. Right on. There is actually other things that helps us see what the derivative is, such as secant and tangent lines, limits of the function, and seeing the relation between the base function and the derivatives of that function.
I know that's right, Chad.
That sounds cool, but unfortunately I'm still having trouble understanding it all.
That's alright. Chad and I can use examples from the party to explain it to you, Jeff. Isn't that right, Chad?
Cowabunga, my dudes. Let's get our derivatives on.
Sounds like a plan to me. I think I can hear the party up ahead.
Off the party car and into the main event.
Let's stick together, guys, so you can help me out.
Oh, don't worry. I'm sure we will see a lot of crazy stuff in here while we're here.
Remember, guys, we're here to have a good time and weirdly learn at the same time.
The learning part is for you to do, Jeff. So you better listen up and listen to Lauren and I, and better not be wasting our time, you punk.
Okay, Chad, chill out. We just got here and you're already too turned up. Let's focus on why we're here.
I do have an idea that can make the explanation of derivatives easier to understand at the party that we could see or anyone else could see.
What example would that be, Jeff?
We could just look at how much everyone is drinking over the amount of time they are here at the party. Just basically how drunk they are.
That's a great idea. Because the more you drink over the time, the more drunk you become. But if you drink the same amount in a shorter amount of time, you're going to become more drunk than the person who drank the same amount but spread it over a further larger amount of time.
So, if our base function is the example I provided of how drunk someone is on the y-axis compared to time, which would be the x-axis, that means our derivative would be how much alcohol someone has drank over the same time period. The less they drink, the less drunk they are, which would be a negative derivative. But the more alcohol they drink over the set amount of time, the more drunk they would be over the same amount of time, would be a positive derivative.
Exactly, my dude. It's great that you are learning even while being in a wild setting.
Now, how would you explain the tangent and secant lines?
When a secant line is formed with 2 points that are very close to each other, the line formed is now known as a tangent line. A tangent line is a straight line that touches a function at only 1 point.
So in other words, the secant line in our situation would be the average rate of change between 2 points of time, which also mean how drunk someone is getting between 2 points of time. For example, between 8 p.m. and 9 p.m., someone could be drinking light, so their average rate of getting drunk is low. But between 11 p.m. and midnight, they could be heavy drinkers, which means they are getting heavily drunk on average.
Okay, that makes a lot more sense. How about the tangent lines?
The tangent line is just the slope of the function at that exact point. Going back to the secant line example, someone starts drinking at 8 p.m. and they're getting drunk at a smaller rate. But if they keep drinking at the same rate, then at 11 p.m. they're getting at a faster rate.
So, the secant line is a straight line that joins 2 points in a given curve. The slope between the 2 points of the secant line represent the average rate of change. And the average rate of change of y with respect to x can be taken within a closed interval. This change in y with respect to x results in our slope, which represents the average rate of change. So if you take your first shot and then you take your eighth shot, the line connecting those two shots would be your rate of change of how drunk you are getting. So this line is also your secant line.
Yes, exactly. Now, let's explain the instantaneous rate of change. Chad, I know you got this one.
Oh yeah, I know this for sure. The instantaneous rate of change of the function at that one point, as the 2 points used for the secant line get closer to one another, the average rate of change becomes the instantaneous rate of change, and the secant line becomes the tangent line. Because there is only 1 point to the tangent line, we have to use limits to find its slope. A limit tells us the value that a function approaches as the function's inputs get closer and closer to some number.
Oh, gotcha. That makes a lot more sense.
Now, I can explain the limits. Knowing this, we are able to talk about limits of a function. When we're talking about the limit of a function, we are describing where the function is going. When taking the limit of a function, it is telling us that h is going to take some value in which is very, very close to 0, but not 0. H is the horizontal distance between the 2 points on the secant line. So saying h goes to 0 means let the 2 points close in on each other. Since h is the denominator of the slope, aka the average rate of change, it represents the horizontal distance between the 2 points on the secant line. That's why when h goes to 0, it gives us the instantaneous rate of change. The numerator of our function would represent our change in our drunkenness, and the denominator in our function would represent our change in time. So when you are at a party for 3 hours and you have been drinking, you hit a drunkenness level of 7. So when you are taking the limit as h approaches 0, you can take the times closer and closer to 3 hours to get a limit closer and closer to 7.
I think I'm understanding everything now. Can I recite it all back to you and you guys can fact check me on this?
Yeah, just make it quick because I'm just itching to get my groove on the dance floor.
If we are given a function, say f of x, which is how drunk you are and x equals the time you've been at the party, if you want to know how drunk you are after 3 hours at the party, then you take the time x and see that as x gets closer to 3, f of x equals 7 on that f of x is 7 on the scale of how drunk you are. So the limit as x approaches 3 is 7. Then the slope of the tangent line at x equals 3 tells how fast you're actually getting drunk after 3 hours. Using that, we are able to approximate how drunk you are, and by using f of x as closely as we like by taking x, the amount of time you've been at the party at values closer and closer to f of x. The slope of the tangent line of the function is equal to the derivative of the function at the same point. This is because when we see that the limit as x approaches 7 from the left and right exists, this means that f is continuous at that 7 level of drunkenness point when it is the point 7 of how drunk you are is differentiable at that point. Thus, it is known that if a function is differentiable at that point, then the derivative exists at that point. The slope of the tangent line of the function is equal to the derivative of the function at the same point.
Yup, that sounds great to me. Now, let's go enjoy the rest of the party.
Let's go. This party isn't ready for my top-notch dance moves. Make way for the next dancing superstar.
Thanks guys, a lot. And you're right, let's go enjoy the rest of this